Who am I? Where am I? What's going on? Many great philosophers throughout the ages have pondered these questions, and yet we supply the answers in less than 15 minutes. We saw in the previous video that all you need to boot a Raspberry Pi is an image file, one that has the .img extension. We downloaded two Linux distributions called Fedora and Debian. We inserted the card into the writer, ran a program called Win32Disk, selected the drive letter allocated to the card reader, this will be different for every machine, and selected the image we wanted to write, and waited. Note the warning, everything on the card is now going to change. All save data will be lost. Now we have two cards, one for each distribution, Fedora and Debian. Let's see what they do the first time they're inserted. Fedora, run the first time. Both distributions contain a small routine to run on the first occasion the card is plugged in. This routine configures the card and asks you to select passwords for your new system. At the time of recording, Fedora is known to be buggy. We'll accept this and plough on for the moment. Don't worry too much about reading the screen, we will sharpen the resolution when it matters. Fedora begins within moments of switching on the power. Unreadable statements fly up the screen. In this initial state, during the very first switch on of a newly written SD card, the machine changes its configuration and reboots twice. On this example here, some of the text is off the screen. This is an error in the settings and can be sorted out later. Eventually you are challenged with a few questions. The first question requires a root password. In Linux, the main administrator is called root, and root is king. You don't get any higher than root. If this is all new to you, then you're known as a newbie. Nothing wrong with that. Everyone has to start somewhere, but here you are, newbie, being offered the ultimate power in your own system. Settle down and enter the password and then again to confirm. Nerves at this stage are understandable. You have a new elevated status newbie to root in a few seconds. The only two mistakes you can make at this point are selecting an insecure password, or worse still, forgetting your own password. Next, you are asked the name of a user account. This is a normal account with no superuser root powers. Just type in a short nickname you wish to use. I'm going to use Dick, all in lowercase. It then asks you for the full name of the user, followed by enter. This is optional, it seems. Then it asks you to set a password for this user. Select a good password. It needs to be entered twice to confirm. Then it asks for the time zone. Being American in origin, Fedora defaults to EDT, Eastern Daylight Time. As I can't see the text correctly on the screen, I'm just going to press enter for the moment. We can change this later. Next, you're offered the option of starting the system in text or graphical mode. A good deal of these early lessons do not require graphics, so N for the time being. None of the options are binding, and all of them can be changed later. Finally, it says click to enter and start the system. Here we go. At the login prompt, enter root in lowercase and enter. Recall the password and enter that too. You are now in Fedora. Here is your first experience in Linux administration. The prompt confirms that you are user root on machine Raspi. The first thing to know is how to shut your system down correctly. Don't just remove the power. The command to reboot is reboot. Power off will also work gracefully. But my preference is shutdown, as it demonstrates the flexibility of flags. Type shutdown -H now. Notice everything is in lowercase. Get used to using lowercase everywhere and even replacing spaces with underscores. But more of that anon. The -H is what is known as a flag. It provides additional qualifications to the command and is used with other commands too, as we'll see later. H stands for halt, whereas R would stand for reboot. Now is pretty obvious, it means immediately. It is possible to specify an absolute time, e.g. 23:30 for half an hour to midnight, or a relative time like +10 minutes, and even send messages to users. Debian for the first time appears to have a lot of red failures. There's no need to worry about these at present. Eventually you come to a line that says welcome to Raspberry Pi one-off installation, and things appear to slow down. A message appears. If we stop waiting for port map, feel free to turn the power off and on again. Only on this occasion, it's normally better to wait. See you later. And in this instance, take this advice and do wait. It takes about 4 minutes to complete the process with an 8GB SD card. It then reboots again and comes up with a prompt. This is where Debian displays a different character, if we can call it that, from Fedora. Whereas Fedora asked us for a password for the root account and then asked us to enter a random username for a user account, along with a full name and password, Debian has thrown us directly into a prompt. Now what's going on here? Well, this version of Debian has been pre-programmed with a standard user account, username Pi, and password Raspberry, all lowercase. Entering these details logs you into Debian and to the familiar prompt. They seem to be insistent that Debian comes with absolutely no warranty, so be warned. Now notice the prompt. Pi at Raspberry Pi. This prompt is once again made up of your username and the machine name you're using. Currently you are the user named Pi, logged in to the machine called Raspberry Pi. These details in the prompt are really useful, particularly later on when you start to connect to other machines across networks. To provide Debian with a root user password, type sudo sh. Notice the prompt changes. Type password and enter, and reconfirm the password. Once again, do not forget this password. Finally, type shutdown -h to shut Debian down for the very first time. We will now go on a quick tour of Linux to become familiar with some of the basics of how the system runs and get a look and feel of what is known as the text interface. You may ask why we should be using this seemingly old-fashioned format rather than the more conventional graphical interface, a GUI as it's known. There are several reasons. First, it gives us a glimpse of what's happening under the bonnet. Second, it tends to be rather faster and doesn't waste resources running the GUI. And finally, it may be more powerful. A lot can be put into one line of text. When you switch on, log in and stare at the prompt, you are at the control of your own small duplicate of some of the largest operating computers. The simple view belies the underlying power of what is known as a multi-user, multitasking operating system. Multi-user means that there can be other people using the system at the same time as you. This is demonstrated in a later networking video. And multitasking means that the system is working in the background on many processes, even though you are just looking at a prompt. It's running many processes at the same time. Now that's a computer illusion. It's actually swapping between a list of jobs so rapidly that it appears to be doing everything at once. So log in. Now the login Taliban are going to hate this next bit as it's truly wrong, and I admit this. Log in as root with the root password to see the prompt. Typically you should log in as a standard user and only promote yourself to root to do the more powerful and dangerous things that could destroy the whole machine if you get them wrong. That is the correct way. But it's your Pi and enjoy the power. More importantly, learn to take risks. The prompt is your indication that the processor is sitting there poised to obey your every command. We did a Who Am I earlier on. This is already given in the prompt. Here the prompt confirms that I am the username root on the machine named Raspberry. We start our tour at this prompt. It's a two-part tour answering the questions, what's going on and where am I? What's going on? The advantage of logging in as root is that you have an overview of everything that's going on your machine. Enter the process status command. This is shortened to PS. Every process running in the Pi needs to be uniquely identified. This is done using a number. Each process has its own process ID, the PID. This number will grow and become large on machines that have been running for a long while. TTY is the name of the connection to the machine, different for every user. The time is the time spent processing the command, and the command is given in the CMD column. Here you can see that there are just two commands, the PS command that we've just typed and a thing called bash. Bash is a shell that interprets the commands when you type them in on the keyboard. But as root, you know that there are many other processes going on in the background. How do we see these? We met flags earlier. We can add flags to the PS command and modify it too. Try PS AUX. Wow, too much information as they say. To control the screen output, type PS AX pipe less. The pipe sign is called a pipe. Less allows you to see the output of a screen at a time. Inside less, press the spacebar to move down and see the next screen, or B to go back up. Q quits and returns you to the prompt. But notice how much more information is available here. It's not necessary to remember any of this at all. This tour is just to experience what is available. The extra columns include user and the percentage of processing power and memory consumed. User shows the user responsible for the process. S in the stats column shows processes that are sleeping. R means running. Note, our PSAUX command was caught running in this snapshot. PSAUX provides a snapshot of what is going on. Top, on the other hand, provides similar information but is more dynamic. It shows what is happening in real time. Processes here jump up and down as the system runs each process. Above the white bar is the time and how long each system has been on, how many users are on the system, and how hard the system has had to work. It shows the tasks, those that are running, those that are sleeping, those that have stopped, and zombies. Yes, some processes can have bugs and just wander off. The next line shows CPU status. We'll return to this later. Mem means memory. We need a lot of fast memory. This line shows the total of how much memory is available. Below the white bar there is good old PID mentioned earlier, and who is using the resource. U, root. The load on the processor is shown in the percentage CPU column, and the memory taken shown in the percentage memory. The overall time taken by the system processing the PID is shown in the time by the command in the final column. When you are finished watching the processes, tap the Q for quit key. Top and PSAUX are good ways of showing what is going on in your machine. The command for checking what is set up to go on in the background is check configuration or check config. You have seen a Linux boot up when you switch on. What this is Linux climbing up a series of steps. Linux goes through states 0, 1, 2 and 3 to get to the text prompt, and to state 5 if you've opted for the graphical interface. Check config lists the available services on your machine and records a note of their state at each level. For example here, you can see that the first boot process we went through earlier is turned on at level 2. There's no reason to remember all this, it's just a brief overview of Linux. It will not be long before the understanding of all of these is second nature. As these services run in the background without your direct control, they're called daemons. These daemon processes are also closed in an orderly manner when Linux is shut down, something that does not happen if you just remove the power. That's bad for any system. Watch more closely what streams up the screen next time you log on and off. A lot of the lines will be related to the services listed here, and you will learn to look for alerts for possible problems in your system. That deals with what's going on. Next, the where am I question. Computers are nothing if not organised. All of the programs and data held on the machine could be held in one big file. Listing them out and sorting them would soon become a nightmare and the whole thing develop into a mess. By filing things away in meaningful areas, maintenance becomes easier. Programs can be called binaries, and system programs could be system binaries. We could sort these away in their own directories. You could have an area for temporary files and another for your media. Another could hold details of what happens during the boot process, and yet another be used as a library for your library files. Needless to say, folk are trying to agree on a common way of sorting things into directories. This is a commonly accepted solution. It may seem to be daunting at the moment, but again, and like everything else, will soon become very familiar. Let's use the Pi and find out how to look around inside the machine. Boot and log into the root account. In Fedora, the prompt confirms again that you are user root on the machine Raspberry. You are somewhere in the file structure, but where? Present working directory is reduced to the command pwd. It's a useful command that tells you where you are in the machine. As a newly logged in root user, you always start off in what is known as your home directory, /root. Okay, so what's in root? The list command has been reduced to ls. Okay, nothing to see. So how do we move around the filing system? This directory appears to be a dead end. We can't move any further down. There's nothing there. So, to move up, type cd .. pwd confirms we're at the top of the tree. ls. This should seem familiar. Bin, boot, dev, etc. These are the prearranged directories you will see on every new system. Again, they will become very familiar as you learn about Linux. If, rather perversely, root is at the top of the tree, then you must have to go down into directories. To go down into etc., type cd etc. This is easy. ls. We have some content here. In the basic setup, Fedora color codes the files and directories. Files are white, directories blue. Let's go down into NTP, Network Time Protocol. CD, NTP. ls. Interesting. Two files and another directory called crypto, short for cryptography, coding, spying and stuff. This could be cracker territory. The name alone makes me curious. CD crypto. ls produces PW. I don't think we need to be a major sleuth to realise what this might stand for. So, how to peek inside? The category command has been reduced to cat and allow us to look inside a file. So type cat pw. Well, how interesting is that? pwd to show where we are. There we are and the path we took to get to this file. The slashes show that we are 3 levels down. There are 2 ways of going back to the top. Type cd ... .. Notice the pairs of dots take us back up 1 level each. Or the quick method, cd / jumps straight to the top root level. Don't get confused by the root of the filing system / and your home root directory /root. They are different places. I'll try to make it as clear as possible as we move along. In / or root, we see the directories mentioned earlier: home, boot, temp. You can stop the video and peek around with the commands you've already used: pwd, ls, cd and cat. Top tip, a quick note. Try repeatedly pressing the up arrow. It shows you a history list of the commands you've been using, and it will save you a lot of time when typing in future. We do not need to move up and down directories one at a time. When you become more familiar with the layout, you can jump to an exact location, e.g. cd var spall mail. Confirm with pwd. Yes, and if we do an ls, we will see what's in this subdirectory. On your machine, this will be different, unless you did as I did when we set up the first Pi and added a user called Dick. Linux made this automatically as it prepared for the user Dick. It will do the same thing for any other user you decide to add later. In fact, this is where the mailing daemon will store Dick's email when it's started in a later video. But that is not what I came here to show you. I wanted you to see the difference between cd ... and cd var spall mail. There is a difference in these 2 examples. cd var spall mail is known as an absolute address, as the location is defined explicitly. cd ... is a relative address, as it moves you up 1 level wherever you are, unless of course you're already at the top level. The command works relative to your position in the file structure. It's a bit like addressing a letter. An absolute address specifies exactly where you are. We've all written without realising we were getting close to an absolute address. Is this an absolute or relative address? Absolute and relative addressing will turn up again. That is worth remembering. Try moving around and have a snoop at what's in Linux. Be prepared for some surprises. If your system's still working, let's return to your home directory, cd/root. Was that an absolute or relative move? ls displays an empty area as before. To make a directory, type mkdir new directory. ls, and there is the new directory. And go in, type cd new directory. ls. Well, of course it's empty. We can carry on putting directories inside directories to our heart's content. If you remember back to the shutdown command, we introduced the idea of the flag. Shutdown -H to halt, shutdown -R to reboot. It turns out that flags work with most commands. ls has some flags. Let's go back to /root, your home. type cd/root, or cd tilde. The little wavy line is called tilde, and it will take you directly to your home directory. Type ls. Now type ls, but the flags -la. Ah, more details have appeared. White hidden files and blue hidden directories. The dot at the front of any name hides it in the file structure. You can see what's inside the files by typing cat and then the file name. Have a play. The ls-la command exposed far more details about the files and directories. The first thing to note was that the blue directories had a D in front of the code on each line, and files had a dash. The rest appeared like some weird Morse code. To understand this, you need to know two things about the way the Pi treats its files and directories. The first is R, read, the ability to read from a file. That seems pretty straightforward. We've been doing that already when we used the cat command. The next is W, write a file. Again, pretty basic. We'll cover this in a later video. And finally, X, execute. This is the nasty side of Linux, where your screen goes blank and it hauls off the file to be shot. Well, it isn't really. Execute here means execute or run a file or program. That's all R, W and X are. Now, Linux was designed in simpler times, when there was you, your mates and the rest of the world. Now, if your mates are put into a group, then all Linux needs to remember is that you can read, write and execute a file, your mates can just read and execute, and the rest of the world can only execute. These settings are generally called file permissions, and they store details of who is allowed to do what. For readability, the owner of the file is in the first column, and the group ownership is in the second. This is a new Pi, so everything tends to be user root, group, root. Jolly no mates, welcome to the world of the lonely geek. Help. Linux is a well-documented system. If you need rapid help with a command, type the command followed by the --help. More fully explained details are available in the manual. This can be easily accessed by typing the word man followed by the command. Up for breath. We've covered a good deal in this video. We've followed the differences in the initial boot processes of the two Linux distributions, Fedora and Debian. We've been introduced to many terms: multi-user, multitasking, file structure, relative and absolute addressing, file permissions, and operating systems. And we've seen sources of help and answered some pretty fundamental questions. Who am I? Where am I? And what's going on?